Welcome back, guys. Sorry about that. Had to clip it, trim it down, and redo this one uh, for reasons of ease for you guys. Okay, this is the tough example. Write an exponential function y equals ab to the x power for a graph that includes 1, 6, and 0, 2. All right, so the first thing I'm going to do is label my points. This is an x coordinate, this is a y coordinate. This is an x coordinate, and this is a y coordinate. It's always that way. When you are given coordinates, it's x, y, unless it's in 3D, and then you have x, y, z. But we don't need to do that. All right, so step one, we want to write in y equals abx form. So using the first point, just because it's the first one, nothing else, we're going to have y is 6 equals a times b to the first power, because we substituted in the 6 for y and we substituted in the 1 for x. Okay, now we want to solve for a. Right, so we're going to solve this equation for a, this function for a. So we have 6 equals a, b. B to the first is just b, so I'm not going to rewrite that 1. Now solving this for a means I need to get this little guy by himself. He needs to be alone. So we are going to get rid of the b on that side of the equation. So we are going to divide by b. And we are left with a equals 6 over b. Now we're going to use this, so I recommend that you keep it nice and clean and you've identified it. Now we come over here and we write second y equals ab to the x. Right, so that's going to be y is 2 equals a, b, and the x in this case is 0. Well, what is anything to the 0 power? Well, this would be 2 equals a times 1, because b to the 0 equals 1. So this equals 1. Well, we have a equals 2, which is what we're trying to solve. And I'm going to show you another example because this one is easier than the hard ones. All right, so we have a equals 2. We take this 2 and we plug it in over here for a, right? So substitute in original equation the a value. And I probably could have said that a little bit better, but that's okay. Okay, so we have 2 equals 6 over b. Well, hopefully mentally, a lot of you guys will be like, I know what b is. If you don't, we're going to multiply both sides by b. That means these b's cancel out, and we have 12 equals, sorry, that's why you have to be neat when you are writing it. That's a b. That's going to be 2b equals 6. Divide both sides by 2, and we have b is 3. Right, so now we have our b value, and we have our a value. So now we have the information to write the exponential function. So the answer is going to be y equals a, which is 2, b, which is 3, to the x power. Okay, so y equals 2 times 3 to the x power. I'm thinking, oh great, okay, I was thinking that that number, or that example wasn't there. So we're going to go ahead and do this one just as a bonus, if you will. Not really, right? These aren't bonuses. But anyway, I will do this one so that you get to see another example where one isn't so super duper easy. That one was easy. Anytime you have zeros and ones involved, it's easy. Okay, so looking over at this one, we are going to label our points again. This is x, this is y, x, y. Number one, we need to do the y equals ab to the x power. I'm going to use my first one. So we have y, which is 4, equals a times b, and the x is 2. See, now this complicates things. It doesn't just disappear. Okay, we still want to solve for a. All right, so we have 4 equals a times b to the, oh, b squared, sorry, not bx. I'm going to go ahead and clean that up. So, oh, that's awfully big. All right, solve for a, and then we have ab to the x. Okay, same principle. I want to get the a by itself. What are we doing to the a in this particular equation? We are multiplying it by b to the x power. The opposite of that is to divide b by b to the x power. And now these cancel out on the right, and you have a equals 4 over b to the x, okay? Or you could have 4b, well, how did that get to be negative x? I'm sorry. That's supposed to be b squared. How did I change that from there to there? So we have b squared. Be careful. Obviously, I'm making stupid mistakes. And if I wanted to move this up, I could just take the opposite value of the sign, because remember, if it's negative, we flip the base. So in order to make it negative, we would also flip the base. So this is the same as 4b to the negative 2. Okay, and you might like it written in that particular way. You'll see. Okay, number 3 is to do the second, y equals ab to the x. Love that ab to the x, don't I? All right, so that gives us y is 16, a, we don't know, b, I'm going to make that a little bit better because I'm having troubles here, ab, and then the x is 3. So we have 16 equals a times b cubed. Same thing, we need to, no. Okay, now we need to sub in a from 2. It's different from what I showed you upstairs, or up in the other one, but that was the fastest and easiest, quickest way to solve that other one. Okay, so we're going to take in this value for a, 4b to the negative 2, and we're going to put it in here. Now, you could have also put it in as 4 over b squared. Either way it works. It does not affect things. It just depends on how you like multiplying your exponents. Okay, so we've got 16 equals a is 4b negative 2 times b cubed. So when we're multiplying powers with the same base, we keep the base and add the powers. 3 minus 2 is just 1. So now we have 16 equals 4b to the first power, or just 4b. Now, obviously, it's easy from here on out. It just falls into place. We divide both sides by 4, and we have b equals 4. This is one part of that equation I need to find. Now I need to get this a value. So I'm going to substitute in that 4 for b over here, and that's going to give me my answer. Okay, so plugging this 4 in over here gives us a equals 4 over 4 squared, which is 16. So this would give us 1/4. Okay, so now we have our a and we have our b. Now let's go ahead and plug that into the final equation, and we would have, I'm actually going to move it up here. We would have y equals a is 1/4, so you can write that like 1/4, and then b is 4 to the x power, or you could do 0.25 times 4 to the x power. Obviously, just changing that from a fraction to a decimal. I know this is the preferred method for many, myself included. Okay. Now, the reason I wanted to leave this space open down here is to show you what it would look like with this one. So we would have 16 equals 4 over b squared times b cubed, which is which is the same as b cubed over 1. It's a little bit disoriented. All right, so we have b squared in the denominator. There's 2 down there, basically, right? There's 2 b's down here, and b cubed means there's 3 b's up there. So we mark out what we have in common, and we have just a single b left upstairs, which would give us 16 equals 4b, which is what we had right there. So, like I said, it really just is semantics. It depends on what you prefer. Okay, hopefully that answered questions. If not, you know where to find me.